Welcome, everyone. I'm excited to kick off our presentation today. We're going to explore how specialized high-tech machines are revolutionizing industries by automating complex, labor-intensive tasks. The title of our talk is How Specialized High-Tech Machines Are Automating Complex, Labor-Intensive Tasks, and our subtitle highlights the hidden revolution that's transforming the way we work. Over the next few moments, we'll uncover the incredible ways purpose-built automation is tackling some of humanity's toughest challenges. So, let's dive in and see what's changing the game. Let's talk about the hidden revolution in automation. While headlines often focus on humanoid robots capturing our imagination, the real game changers are the specialized machines. These are purpose-built systems designed for very specific, demanding tasks. They quietly transform industries by taking on jobs that are dirty, dangerous, or dull, without making a big fuss about it. For example, handling hazardous materials or working in contaminated environments falls under the dirty category. Then there are systems operating in extreme conditions that would be unsafe for humans. These are the dangerous tasks. Lastly, we have machines performing repetitive, precise tasks for hours on end, which are often dull but essential. These innovations are having a profound impact, yet they operate behind the scenes, driving efficiency and safety across many sectors. Now, let's explore the four main types of automation that power specialized machines in manufacturing. First, we have fixed automation. These are machines built for repetitive, high-volume tasks where precision is critical. Think of robotic arms on assembly lines. They perform the same task consistently, ensuring accuracy and efficiency every single time. Next is programmable automation. These systems are quite flexible. They can switch between different tasks or products with ease. This makes them perfect for production runs that involve multiple product lines or batches, giving manufacturers agility without sacrificing quality. Then we have flexible automation. This is a softer form of automation that allows for rapid changeovers, especially useful in industries like textiles, food processing, or paint manufacturing. The goal here is to minimize downtime when switching between products, making the production process both quick and adaptable. Finally, we come to integrated automation. This represents the pinnacle of modern manufacturing, fully autonomous plants. These facilities combine robotics, smart controls, and artificial intelligence, allowing operations to run with minimal human intervention. It's an exciting glimpse into the future of manufacturing, where everything works seamlessly together for maximum efficiency. Connecting all these types, it's clear that automation is not one size fits all. Different applications require different approaches, but all aim to improve productivity, quality, and flexibility in manufacturing processes. Robotic planters are truly transforming the way we think about traditional farming. These machines act as the silent workforce of precision agriculture, capable of planting vast areas with incredible accuracy. What's really impressive is how they reduce the need for manual labor while actually increasing crop yields through smart, targeted deployment. Thanks to AI-driven vision systems, these robotic arms can plant seeds at the perfect depth and spacing. They're constantly adapting to soil conditions in real time, which means they're optimizing germination success on the fly. You'll notice that the planting process is about 50% faster, cutting down the time it takes to complete planting tasks significantly. And because these robots can operate 24/7, they ensure continuous planting without the limitations of human working hours. This not only boosts efficiency, but also keeps human workers out of harsh field conditions, making farming safer and more sustainable. Overall, these robotic planters are a key part of the future of agriculture, more precise, faster, safer, and smarter. Let's dive into how drone sprayers are becoming the sky's new farmhands. First, let's talk about extended range technology. Hydrogen fuel cell-powered drones, like Heaven's Z1, can fly up to 450 miles on a single tank. This is a game changer because it allows for much larger areas to be covered without needing frequent refueling, drastically improving efficiency in the field. Next, we have precision application. These advanced targeting systems ensure that chemicals are sprayed only on the affected areas. This means we can reduce chemical use by up to 30%, which not only cuts costs, but also minimizes environmental impact. It's a smarter, more sustainable way to manage pest and weed control. Finally, let's look at sustainable infrastructure. Mobile hydrogen stations enable these drones to operate remotely and sustainably, without relying on fossil fuels. This brings clean energy right to the field, supporting a greener and more environmentally friendly farming process. All these innovations tie back to our overall goal: making agriculture more efficient, sustainable, and environmentally responsible through advanced drone technology. Let's take a closer look at our case study, AES's Maximo robot. This innovative solution is truly revolutionizing how we approach solar farm construction. What makes Maximo stand out is its ability to bring engineering excellence into some of the harshest environments, extreme desert conditions where human workers often face significant challenges. Maximo uses advanced AI and machine vision technology to automate tasks like heavy lifting and precise installation. This means it can operate efficiently and accurately even in environments that are brutal and unforgiving. By automating these demanding tasks, Maximo helps reduce costs. We're talking about up to 50% savings on build expenses, which makes solar projects more affordable and scalable. In addition, Maximo accelerates project timelines, leading to about 50% time savings. Faster completion means we can bring renewable energy sources online more quickly, contributing to our overall goal of expanding clean energy access. This case really highlights how purpose-built automation can excel where traditional methods struggle. It's a perfect example of how innovative technology is making renewable energy projects more accessible and efficient, even in the most challenging conditions. Let's take a closer look behind the scenes at how these advanced machines are built. Specialized engineering firms like SDT Products and Big Sky Engineering play a crucial role here. They develop custom automation solutions by integrating the latest in robotics, vision systems, and precise handling technologies. One key example is the dual SCARA robot systems. These are sophisticated setups designed to punch, sort, and transfer hundreds of metal parts per cycle. What's remarkable is their near-zero error rate, which means they deliver industrial-scale precision every time. Another important aspect is their design for continuous operation. These machines are engineered to last for years, with minimal downtime, so they can run 24/7 with routine maintenance. This reliability is essential for high-volume production environments. Finally, each machine is custom-built to meet specific production challenges. They combine multiple technologies into seamless automated workflows, ensuring that the entire process is efficient, reliable, and tailored to the needs of each client. All of these elements come together to support the overall theme: how cutting-edge engineering and automation are transforming manufacturing into a highly precise and efficient process. Let's explore how software truly acts as the brain behind modern machines. First, we have intuitive control. These are user-friendly platforms that operators can pick up quickly, reducing training time and increasing efficiency. Next is AI optimization, which allows for real-time adjustments, ensuring the equipment always performs at its best. Then, remote monitoring gives us the ability to track and maintain systems from anywhere, offering greater flexibility and quicker response times. All of these elements work together to turn complexity into simplicity. Modern automation software transforms what used to be complicated machine programming into workflows that are easy to understand and master. Offline programming capabilities, combined with AI-driven adjustments, significantly cut down setup times, from days to just a few hours. This not only reduces material waste, but also maximizes production throughput. In essence, these advancements make our manufacturing processes smarter, faster, and more efficient, aligning perfectly with our goal of optimizing performance through innovative technology. Let's talk about the impact of automation across three key areas: efficiency, safety, and sustainability. First, economic efficiency. Specialized automation significantly reduces labor costs, which is a huge advantage for companies. But beyond that, it also boosts product quality and consistency, no matter how many units you're producing. This means fewer defects, happier customers, and a stronger bottom line. Next, safety. Automation removes humans from hazardous environments. Think dangerous machinery, toxic materials, or extreme conditions. This not only protects workers, but also minimizes accidents and injuries, creating a safer workplace overall. And then, there's the environmental benefit. With automation, resources like water and chemicals are applied more precisely, which cuts down on waste. Plus, using electric and hydrogen power systems helps lower carbon emissions, making operations more eco-friendly. All in all, industries, from agriculture to aerospace, are seeing transformative productivity gains. These advances are reshaping competitive landscapes and opening up new opportunities for sustainable growth. It's clear that automation isn't just about efficiency, it's about creating safer, greener, and more resilient industries for the future. The future of automation is definitely heading towards specialization. As technology advances, we're seeing more sophisticated niche machines emerging. These are designed to solve very specific, complex challenges that general-purpose machines simply can't handle as effectively. This trend is all about tailoring solutions to meet unique needs, making processes more efficient and precise. Strategic investment plays a crucial role here. Organizations that recognize the value of adopting these specialized solutions today are positioning themselves for a significant competitive advantage tomorrow. By embracing these innovations early, they can optimize operations, reduce costs, and stay ahead in their industries. Looking ahead to a sustainable tomorrow, these specialized machines are unlocking unprecedented levels of efficiency. They also promote greater environmental responsibility, helping us reduce waste and energy consumption while maintaining high productivity standards. Ultimately, what we're witnessing is a quiet revolution, one that's reshaping the way we work and produce. These machines are not just about automation, they're about precision, safety, and sustainability. They're enabling us to tackle humanity's toughest challenges with smarter, more responsible technology.